Hey guys, so for today's lesson, we're going to be talking about the parts of an equation and proportional relationships within equations. So what it's going to kind of look like is tying in 7th grade equations and 8th grade equations with unit rate that you learned a good bit in 7th grade. So if you're looking at your post, whether in my class, Miss Henson's class, or in Miss Hutchinson's class, we both assigned this 2-page document as your assignment. So kind of start getting in this routine in that I'm going to work out this first page with you as your notes. If you'd like to pause it right now and print it, or if you'd like to open the document within Google Classroom to follow along with me, you can do so. And then we'll require you to submit the second page as your assignment by 7 p.m. tonight. Okay, so I'm going to go ahead and get started. Again, please feel free to pause as much as you need to. I'm going to write a good bit on this, so if you need to catch up with me, please do so. So first I'm going to start with, this is kind of the 7th grade equation. And this would be like the corresponding 8th grade equation that we're going to be talking about. So in 7th grade, you learned that K was unit rate. And that's still true here. We're going to call this unit rate for now. And in a few weeks, we'll call it slope. But for right now, it still has the same purpose. It is still a unit rate. Also in 7th and 8th grade, it never changes that our X and Y is still a coordinate pair, right? So that part is never going away. It's still a coordinate pair. It's still comparing where X is kind of like that counting number a lot of times, multiplying it by the unit rate, you'll get a total amount. A lot of times in 7th grade, and what we're going to do today, you would get that Y, when you use Y equals KX, you would know that Y divided by X equaled your constant. And we're going to do that a good bit today too. So just if you haven't labeled it already, this is kind of like what we did in 7th, and this is what we did in 8th. So the new part that you've kind of wondering about in 8th is this plus B, which we'll talk a little bit about today, but slowly kind of build to in the next couple of weeks. The biggest part going from 7th to 8th grade is that every situation we talked about in 7th grade started at 0. It started at the origin. So all these started at the origin. Okay. Whereas in 8th grade now, they don't have to start at the origin. So that might look like something like instead of saying that I started walking so many miles, I might have started at 20 miles and then started counting a situation. Or I didn't open a bank account at 0. I opened a bank account with $500. So I can't start at 0 in that situation. I need to start at 500. So this is going to be called your y-intercept. And even if we don't learn that fancy word yet, we just simply need to say that this is where this equation starts on the y-axis. I'm sorry, I'm running out of room there. And we're going to talk a little bit about that today, but mainly we wanted you to see just kind of the difference in the big picture of your 2 7th grade to 8th grade equations. So I'm going to go ahead and jump right into this one right here. This does line up with lesson 10, proportional relationships. This is actually one of the first problem set problems, but we actually changed it to work out a little bit prettier than it did in the book. So questions are the same. We're going to use this one because it works out to not a terrible fraction. So I'm going to say that Eamon walks from the store to her friend's house 2 miles away, and it takes her 40 minutes. So we're going to both focus, Ms. Hutchinson and I, on before you do anything else, the most important thing in this is going to be to identify your X and your Y. And hopefully you do remember that from 7th grade. So if this is saying to determine Eamon's constant rate of miles per minute, then it literally means that I want to know how many miles per 1 minute. So I need to figure out that if this is going to be miles per 1 minute, then what I'm solving for is my 1. And if you're getting confused on, well, how do I know what to label for X or Y? Well, then we want to know how many miles in 1 minute. So this would be your miles, and this would be your minutes, okay? So I'm going to say that y equals kx is the equation that I'm going to use here. What I need to figure out here, and this is kind of where we get kids stuck, is I know these are numbers that you're probably already dividing in your head. If we're talking 40 minutes, hopefully we're starting to remember this part right here from 7th grade and dividing it by 2 miles, because this would be my y and this would be my x. And of course, 40 divided by 2 would be 20. And hopefully this is kind of jogging back 7th grade like we wanted it to. Our constant rate for this situation would be 20 minutes per 1 mile. So what we want to say here is that y would equal 20x. And now we have our equation. So I'm going to plug in this. This would be my 2. If I plug the 2 in the equation, you of course would get your y would be 40, and vice versa. If you plugged in your 40 for your y and you divided, you would get your x is 2. So what I'm going to have you do is, if you want to pause the video for a second, I'd like to see if you can kind of fill in A and B. I'm going to ask you what words represent x, what words represent y, and what is their constant rate. Most of that you can just fill in from here. So if you paused and you came back, this would represent where x in the situation would be miles, y would be minutes. What is their constant rate? Well, we did that. We did division of y equals kx equation to get her constant rate of being 20 miles per minute. Now we're going to fill in some more of these x's. So I'm going to fill in 4 and 7 like it tells me to do. I'm going to use the equation to fill in my corresponding y's. Now, we know at this point this is just going to be basic multiplication, but obviously what we're going to be leading to here is it's not going to just be one-step equations anymore. We're kind of guiding you to get ready for those 8th grade equations here. So humor us and fill in your constant rate for both of these. So both of them start off with y equals 20. And then we're going to plug in the x that we're asking you to plug in. So in this case, 4, and in this case, 7, right? And of course, this means if I were traveling 4 miles, I could do 20 times 40. And I know Eamon, not me, Eamon would take 80 minutes. And then 20, plugging in 7 for x, which would be miles. Then we could do 20 times 7, and it would take him 140 minutes. So this is filling in the table up here. Letter D down here is one of the most important points we want to get across to you. And honestly, it should be the easiest ones. And it's what I boxed out up here. So it says to write a 2-variable equation. Sounds complicated, but we've already done it. To represent how many miles Eamon can walk over any time interval. So when we ask for a 2-variable equation, in this lesson and our next upcoming lessons, you're going to be plugging in a whole lot of numbers. If we ask you to plug in x and y and things like that, if we just want a 2-variable equation, we want the equation for any situation when we're talking with Eamon and his miles and minutes. So in this case, the only number you should be plugging in is the constant rate. So in this case, my constant rate is 20. I want to keep this y there so I can put any y to find out any x, or I can plug in any x to find out any y. This is the equation, the 2-variable equation, 2 variables, that I can use for any of Eamon's situation. So this is kind of like your full worked out example. If you notice on the next page, of course, pause as needed if you're not done copying. But on the next page, you still see that this is kind of getting into the 8th grade one. And then we kind of have more of a 7th grade one for you to complete on your own. If you notice this one, this talks about how Dave travels at X hours. So you're just going to plug in for any number of hours times 50. So this is literally plugging in number of hours. This situation didn't start at 0, like I was saying before. So this is one where he would have already traveled 15. So if he's driving 50 miles an hour and you're just plugging in those number of hours, it's really no different. You just have to account for the 15 that he already drove. So for this first one, you're simply going to write the equation of y equals 50 miles per hour. Let's see how far he did for 2 hours. We got to account for the 15 he already traveled. And then you multiply this out to figure out how many miles. 50 times 2 is 100. And 100 plus the 15 he already traveled is 115. So you'll complete the rest of this one. And this is very much similar to the one on the first page. So you're going to complete all of the table and all of the lettering here. Ms. Hutchinson and I both are okay with you submitting this typed in. If for some reason you can't do that and you'd like to send a picture of your work, that's fine, but you need to attach it to the Google document and submit the assignment by 7 p.m. Please email us if there are any questions, and have a great day.